Welcome back to the Automation Podcast. My name is Shawn, and this week on the show, I meet up with Mohler from Pi Control Solutions to learn all about their new product, SUPERTUNE. Yvonne, thank you for coming on the Automation Podcast. It's great to have you back to talk about SUPERTUNE. Before we jump into your presentation, though, could you take a few seconds to introduce yourself to our audience?
Okay, not a problem. Thank you very much for having me back. And my name is Ivan Mohler, and I'm a senior process control engineer inside of Pi Control Solution. And if I can get like a few seconds just to maybe repeat some things what we have done from the past in order to refresh uh, some memory. So Pi Control actually it is international process control and automation company, and it has been formed 1997 with the headquarters in Houston, Texas. And mostly we are OEM equipment manufacturer of process control software, and we are experts in primary and advanced process control. And also we have become the worldwide leaders in industrial remote process control training and education. And up to today, I can say that our complete technology has been applied in more than 70 universities worldwide and also more than 100 industrial plants worldwide. We have more than several alliance partners across the globe, but maybe for now, this is not the most interesting part. So let me maybe start with today's topic, and actually it is a super tune. For some of you, maybe it is a typical auto tuning package, what you might have seen in many DCS, PLC, or standalone applications inside of the industrial plants. But definitely today you will see that this name or this product, SuperTune, it is uh, far more different than a typical or any kind of the existing auto tuning package, what you might have seen. So probably you are aware that today plants can have something up to maybe 50 to 3,000 PIDs. And probably you're aware that at any certain point of time inside of the plant or any kind of the process, what we call manufacturing or chemical process dynamics can change and definitely with time will change. Or probably people will change their equipment. And as we know, there is no to exactly the same valves or to exactly the same pumps or something. So definitely there will be some difference. And also with the time, process dimensions will change. All new instrument will become old instrument, and they will start to fail, and new control valves will become old control valves with the time, and they will start to stick. Also, probably you're aware of that many chemical processes are nonlinear or consist nonlinearity inside of their performance. And also, even many of today's plants are heavily automated and well optimized, and many of them are probably stable. Definitely, there is opportunity for improvement and more optimization and PID tuning because we have seen that not all the PIDs in all the plants are tuned or are tuned well. And also, probably you know that today's plants are heavily interacted. One heater is not only a heater for one unit, but it is also a cooler for another unit. There is integration of mass and heat balance in order to save more and to produce more. And then definitely you're aware about the things that one unit can serve for maybe production of several products. So definitely in this kind of the units, you will see continuous changes of conditions and continuous and constant changes of process equipment or maybe some kind of the economical constraints what are imposed on that different section of the plant or that particular unit. So all these things what I have mentioned above, which maybe are good today, but definitely good will be good tomorrow, will cause your primary PIDs, or how I like to call it, base layer PID controls, to deteriorate over the time. And the problem is that your control room staff cannot watch and improve all these controllers daily. And because of this deterioration of the primary process control, if you have advanced process control on the top of it, the APC or advanced process control will also deteriorate over the time. And in some cases, this kind of the deterioration can cause irregular or unwanted plant shutdowns or definitely some other unwanted scenarios.
I got to add in here too, because the deterioration happens slowly over time, typically, it's almost impossible for the control room staff to even recognize it's happening. It's like a frog sitting in boiling water. It typically happens extremely slowly over time. And it's so nobody ever even notices that something's out of tune. But go ahead, let me turn it back to you.
Yeah, I agree with you. There are two ways how this can happen, definitely slow over the time, or maybe suddenly your management got a request that they need to load up the unit more and they are going to some new operating conditions in order to increase the capacity of the unit, and they are going to nonlinear stages of these controllers and this plant behavior. And because of this sudden change or load up, definitely controllers are not so robust so they can handle all these nonlinearities. And then maybe because of that, these controllers will start to cycle or become very sluggish, and then the production or the efficiency in that new stage of operation will be so good as people are expecting to. So an existing auto tuning packages, what might you have seen in many DCSs or PLCs, which are normally embedded functionalities, or maybe there are some companies which are just providing standalone software for auto tuning, work in the way that there will be process control operator or process control engineer or some vendor guy who will come to the plant. He will turn on this auto tuning package, and then he will need to pick up a certain loop what he needs to tune or what he feels that needs to be tuned more, and then he will put this controller in manual, and then either auto tune package itself or the operator, plant operator, will need to do this kind of the step tests when the PID is in manual. So actually he will need to do, or the auto tuning package will need to do several step tests of the valve position, right? And many times this is either time consuming for a sluggish controllers or temperature controllers, analyzer controllers, or maybe purity or property controllers, which are very slow controllers. And many times this is not possible to do because you don't have that stability in the plant and you don't have that time to wait for a complete step test to be done correctly. And as you're probably aware of, that many plants are impacted with continuous strong and dominant disturbances, and it's not that always PV is on the set point and everything is stable and flat. Then other competitors can do the same thing, but they will brag about the situation. Then they can keep the controller in automatic mode, but still they will need to do step tests in order to tune this controller with the auto tuning package, and then it will look like step testing of the set point several times. So the similar thing. And once this is done, eventually when it is done, and if there is a possibility or capability to do that, then auto tuning package either will recommend new tuning parameters what somebody will download to the DCS or a PLC, or auto tuning package will automatically download these new parameters to the DCS or a PLC. And then that human being which was turning on that auto tuning package will say, I have done my job. It will turn off the auto tuning package and it will go home. But maybe 1 hour later, 3 weeks later, 6 months later, this controller will again become unstable because of changing conditions in any kind of the plant or different operation modes or whatever. But then what? And you will get oscillation or you will get poor control. Then you need to bring back that person again to the plant, or you will need to turn on the auto tuning package, again select that controller, again tune it, and again turn it off and go home. So many times it is like a feedback action of the tuning, which many times it is too late, right? So in most cases, all these auto tuning packages, what they can do and what we have seen that they are doing, they can only do a fairly decent job for self-regulating processes. And these are processors or controllers which, once you change a valve position maybe from 50 to 55, you will see that maybe your flow will increase to 100 to from 100 to 105. So they will reach like a new steady state point, and then they will stay there. But in any kind of the plant, you don't have only self-regulating processes. You have also runaway processes. You have ramped or integrating processes, like any kind of the level controller it is. If you make a valve position change on the level controller, you will see continuous ramping on the level going up, even in the bucket or a distillation column or in the tank, and then there is no new stability of this kind of the level indication, right? So for this kind of the complex situations where you have runaway processes, integrating controllers, this kind of the auto tuning packages many times fail. And also they also fail many times if you want to tune very slow controllers, like temperature analyzer controllers. And many times these slow controllers are moneymaker controllers, because what is the most important thing in the distillation column? Temperature profile and composition profile, right? And these things takes time. And the other thing is that many of these auto tuning packages which exist in any kind of the world today, they are, I would say, mostly one-time on-demand tuning. You will turn it on, you will turn it, you will tune something, you will turn it off and go home. But there is no continuous monitoring of what is happening with that controller later, right? So what we have done, we have actually invented a new technology and actually a new concept, which is called the SUPERTUNE.
Before we get to that, I have a special announcement. I've just released my very first book. It's an ebook and it's entitled Logic's Book of Knowledge. What I did is I combined all my Control Logix articles from the last 10 years into an ebook. I updated them, I added new pictures, and I made it all available for just $9.99. So if you appreciate what I'm doing, if you want to support the show and the channel and the blog, then please check out my brand new ebook, Logic's Book of Knowledge, which you can get over at theautomationblog.com/BOK1.
And actually, SUPERTUNE can do far better job and more better job than any kind of the auto tuning package itself. First of all, it is not dedicated to a specific vendor. It can be connected to any kind of the PLC or a DCS, just over the OPC or a DLL functionality, however it's decided. And then what it can do, it can tune PIDs without doing any kind of the step tests. If you recall the previous slide, people or auto tuning packages are doing step tests in manual mode, or they are doing step tests in automatic mode in order to gather the data and tune the controllers. But in SUPERTUNE, you don't have to do any kind of the step tests in the plant. And if you have oscillatory controller, or if your controller becomes deviating PV from the set point, then SUPERTUNE will detect this kind of the behavior, and automatically it will be triggered and it will optimize the controller. Also, you can use SUPERTUNE to completely tune or auto tune your operation from a complete startup to the full operation. And probably you're aware that at the startup mode, there are certain conditions of the process. At full operation or a steady state mode, these conditions will change, and there is a non-linearity in fact from the startup to the full operation. And many times there is no one set of tuning parameters which can fully work for both startup and full operation of the conditions inside of the plant. But having SUPERTUNE, it can take care of all these scenarios, and whenever it sees that controllers has changed from one operating region to another where it doesn't act as a stable controller, it will detect this kind of the bad behavior or performance of the controller, and automatically it will be triggered to on, and it will stabilize the controller. Also, one more thing where what SUPERTUNE can do and others cannot do so far is that you can keep your slave controllers in the cascade mode or automatic remote mode, like how it is called in the PLC world, and you can tune these controllers on the fly without breaking the chain or doing any kind of the step tests in the plant. So imagine in any kind of the plant, every fifth controller or maybe every 10 controller, it is a slave or a secondary controller where the mode is set to cascade mode. And now you don't have to break a chain. You don't need to do step testing on the disk controller, but you can just use a SUPERTUNE and it will automatically on the fly tune all these cascade controllers. Also, what SUPERTUNE can do, it is to tune not only self-regulating processes, which can reach a new steady state value and keep it there stable, but also it can tune integrating or RAM processes, like maybe very slow pressure controllers, or every level controller is an integrating process as well. And also it doesn't care about, do you have like a super fast PIDs controllers having dynamics in milliseconds, or do you need to tune super slow distillation controllers, or maybe some reaction controllers where dynamics are actually range in hours. So it can do both. Simultaneously, it can tune super fast controllers and it can tune super slow controllers. An excellent thing about the SUPERTUNE, it actually works 24 hours per day, 7 days per week, and it's not on-demand auto-tuning package, which is triggered on, and then after tuning, it is triggered off. And it can work with any kind of the PID equation. There are different auto-tuning packages which can tell you that they are just working with Honeywell DCS PID equation or Siemens DCS PID equation. But since we are vendor neutral, we can work with any kind of the PID equation. So these are the benefits what I wanted to highlight through this slide. And the last thing what I wanted to say is that many of these auto-tuning packages can only tune loop per loop, one loop at a time. In SUPERTUNE, you can simultaneously put 100 loops, and simultaneously SUPERTUNE will tune 100 loops at a certain time period when it feels that a certain controller has deteriorated. So this is the best thing about it. So if we go on and if we take a look at typical control problems, what you can expect, let's say like you have a constant set point and all of a sudden you are getting like a rising oscillation, or you are getting like a continuous stable oscillation of a PV or around the set point. These kind of the controllers for many auto-tuning packages are the nightmare, because here you don't have a set point change, you don't have a stable controller. But for SUPERTUNE, this is not the problem. SUPERTUNE will detect this kind of the behavior at the early stage of happening, and it will optimize this controller to be stable again. Or if you have this kind of the situation where you have, again, flat set point, no step changes or a set point changes, and all of a sudden your controller becomes very, very sluggish and PV deviates for a long time period from the set point. SUPERTUNE will also detect that automatically, and it will go to the action module, and it will tune this controller in order to bring back the PV back to the set point. Or if we take a look at the scenario where you want to do like either a ramp set point change, or if you want to do like a stepped set point change, but you realize that your PV is, I would say, almost never reaching the set point. It is very slow and sluggish response of your controller. This kind of the controllers, excellent for SUPERTUNE. SUPERTUNE will detect this and automatically it will tune this kind of the behavior of the controller. Also, there can be cases where people are using like a trial and error methods or old-fashioned Siegel-Nichols method, and they put very aggressive tuning parameters. And once they do a set point change on the controller, they see like overshoots and like decaying oscillations, and eventually controller stabilize. This is definitely not the best or the optimal controller behavior, but SUPERTUNE can detect this bad behavior of the controller, and it will jump in and tune controller more precisely. And the last thing I was mentioning, either if you take a look at maybe secondary or slave MPC controllers, which are the primary control, which is the primary control layer or any kind of the MPC system, or if you take just a cascade controllers or a secondary controllers, which has a complex trajectory of the set point. For SUPERTUNE, this is not the problem. You don't have to break a chain, turn off this controller and do step testing, but you can take this kind of the complex trajectory of the set point and the PV movement, and SUPERTUNE will detect if this controller is too sluggish or too aggressive, and it will help also the cascade controllers. So how SUPERTUNE works in the few steps. So first, it connects through the OPC or through some other way of the communication to the real process or a real DCS or a PLC. Then it reads PV process value, set point, output of the controller, mode of the controller, and PI tuning parameters, proportional and integral tuning parameters, existing one from the DCS or a PLC. It automatically does data analysis, and if it feels that for a certain controller, it should retune this controller, it will go to the tuning algorithm and it will generate new tuning parameters. Then it will either give you like advisory if you adjust that functionality, or it will automatically download the new tuning parameters to any kind of the DCS or a PLC, and then the circle will just continue with the improved control action of your plant or of your process, how it should be. So more or less, this is like a small presentation what I have prepared for you. And now I would like to give you actually a demo. So currently I have set up SUPERTUNE, as you can see on the left side, for loop 1 and loop 2, just to tell you that I'm gathering two different PID controllers data, PV setpoint output and mode. And also on the top of it, you can see the first row, it says like loop 1, and PV is around 35, setpoint's 35, output is 6%. We are in automatic mode, and current proportional action or parameter is 5.26, and current integral action is 45.8 seconds. And also the similar thing you can conclude by observing the second controller. And since the second controller is slightly faster, and not to waste time, because this is just a demo, if people want to see how it works for slow controllers, they can easily reach us later and we will give them extra demo. Now what we will do, we will make unstable the slave controller or the second controller, and we will show how SUPERTUNE works. So what we have done, we have connected the SUPERTUNE to the OPC server, which is not only an OPC server, but it is also a simulation platform for a PID controller. Okay. So as you can see, two trends moving in the real time. The red line, it is the PV, and the black line, it is the set point. And the bottom trend, it shows the behavior of PID output, or we can say the valve position. And now here you can make a set point change. You can put controller from auto to manual. You can change proportional integral action of the controller. You can add disturbances and many other things, but this is not the topic of the situation. So what I will do, I'm now simulating this kind of the controller. You can see the set point is 50. If I go to SUPERTUNE, here the set point is 50, right? And PV is around the set point, and output is 50%, and tuning parameters are 0.048 and 21.4. Let us read it from here, 0.048 and 21.4. So this is the controller which is actually sending the fresh data to the SUPERTUNE. So now what I will do, I will pretend that either somebody has activated the pump, shut down the compressor, went from one region to another region of the operation, went to the non-linearity, made controller unstable by maybe tuning controller and put some aggressive tuning parameters, and I will make this controller completely unstable without any need to change the set point or to conduct any kind of the step tests, okay? So I will put here under the proportional 1, and I will put under the integral 3, and I will go back to the SUPERTUNE. So now with the time, the red line, it is the PV, and the yellow one, it is the output. This controller, if you follow the right part of the trend, will become unstable. And I will not change any kind of the tuning parameters, or I will not change any kind of the set point. But now you will definitely see that once it becomes unstable, at the early beginning of instability, SUPERTUNE will detect this instability. And if you look under the right side where it shows P new and integral new, it will give you new calculation immediately of tuning parameters in order to stabilize this unstable controller what has become. So currently tuning is 1 and 3, what I have said deliberately to make controller unstable and oscillatory. And now with time, new proportional is 0.63, integral is 52. And after a short period of time, you will see that this unstable controller, which can be unstable because of many other situations, what we have said, will again become stable, and PV will reach set point very nicely. So now definitely you have seen that either the red line, which is a PV, or a yellow line, which is the output, has significantly reduced the waveness or the shape of oscillation. And now you can see that the new proportional, it is 0.319, and new integral is approximately 52.87. So SUPERTUNE automatically detects instability in the controller without doing any kind of the step changes, waiting for the stability, and conducting any kind of the steps. And automatically it improves tuning parameters or the controller in order to make it more stable and again to make it very smooth and good. So now as you can see, the red line becomes stable and the yellow line, which is the valve position, also becomes stable. But SUPERTUNE is still not happy because the red line is not on the top of the set point. There is a deviation, right? So SUPERTUNE again detects that, and now it is slightly changing tuning parameters in order to bring back the PV, which is the red line, back to the set point, which is that, I would say, light blue line, right? We can agree on that.
Mm-hmm.
So with a couple of more seconds, you will see again stability based on this ugly oscillation what has been produced because of numerous reasons what can happen in the plant, right? And automatically SUPERTUNE now, at the beginning when everything was stable, what I'm circling with the mouse, when everything was stable, was in the monitoring mode. And you can see advisory message SUPERTUNING monitoring in progress. And now again, once everything is again stable, SUPERTUNE will go to the monitoring mode. While controller was unstable or maybe completely sluggish, SUPERTUNE went to the action module and it did the calculation in order to improve the controller behavior. So how it can do that for one controller, it can do that for hundreds of the controllers simultaneously. So if there is no need for a controller to change tuning parameters, SUPERTUNE will not do that. If there is a need, SUPERTUNE will recognize that at the early stage of the beginning, and it will automatically adjust tuning parameters in order to make controller, again, very, very stable. And now people can ask themselves, okay, now you're getting some stability, but let's see how now this is acting on the set point change, because mostly people are changing set points in their plants, right?
Mm-hmm.
So let's do a set point change. And let's maybe change the set point from 50 to 60. Okay.
Mm-hmm.
And let's go back to the SUPERTUNE. So we can see now the blue line has changed in the step manner. So it went from 50 to 60. We can see very nice proportional kick on the output or valve position. And now let's see how the response will be on the set point change with the same existing tuning parameters what SUPERTUNE has produced based on completely oscillatory controller. So as you can see, it very quickly reached the set point. There is some small overshoot which can be improved after this set point change, because also it takes into account set point changes if there are set point changes. But probably you're aware that not all the controllers in the plant have continuous set point changes. But again, with the same tuning parameters what were served to stabilize unstable controller, it did a decent job and very good control action on the set point change.
Yeah, so for the audio audience, we had a little overshoot when it changed, but it seems to be right back. After that small overshoot, it's right back on the set point again. If there's any oscillation, I can't see it. You're always going to have a little
Yeah,
flutter there, but yeah. So yeah, very nice. So what
yes.
the tuning it did at the other set point, it seems to work fairly well for this set point as well, for this range.
Yeah, definitely. And the first tuning was not made on the set point change, but it was made based on the completely unstable controller when the set point is flat, not change. And now SUPERTUNE, if it sees opportunity, it will grab this set point change, which is a typical or a normal plant operation set point change, and it will calculate your process gain, which is 6.7. If you take a look at the theoretical perfect gain of the process, it is 6.5. So it's very accurate on the process gain calculation. Also, it will calculate horizon estimation, which is actually time to steady state or stabilization time of the controller. It will give you the percent of the proportional kick, how large is your valve position change in the initial second when you change the set point. It will give you PV overshoot 15% above the set point change, which is fairly nothing. It will give you set point reach time calculation, how quickly your PV will reach a new set point. It will also give you a flag if there is a continuous external disturbance which is causing your controller unstable and not be able to tune. Then it will raise the flag and it stop tuning this kind of the controller. And eventually it will give you new tuning parameters, what you might have seen what was doing before we changed the set point. And now it is also considering this set point change And now if we make another set point change, you have seen that tuning again has changed because we have done a good set point change. It is a decent set point change. And now let's observe how controller will act with the new set point change if there is a new set point change made by the process
Now, I
operator,
just
right?
want to jump in here and say that while after it had gotten back in control, it did update the P. So the
Yes.
it did go went down to like 0.169 from like point 0.3. So I had done that while Even was talking. So now you've just you just changed the set point again back down to 50, I believe.
Yes, I changed it back to 50, and now you can compare the set point change before and after, and you can see that it is even better and even improved.
Yeah, it doesn't look like it's going to overshoot very
Yeah,
much
there
at
is no
all.
overshoot. Yeah. So in a nutshell, this is how SuperTune work, and this is the technology which we wanted to share across the globe and with other companies as well.
Yeah, no, I got a question though. If I have a lot of, is there a guide? Do you have a guide for what kind of horsepower you need to be able to do like 100 loops, right?
Oh,
So
oh
that
yeah,
seems like it's going to require a beefy computer.
yeah. So definitely for 100 controllers, we will need like a more powerful PC in the terms of CPU and RAMs, definitely. But the good thing about all these things is that interface is eating a lot of space, so we can definitely reduce the interface so it can be much simpler. And another thing what definitely I would like to highlight, it's not that all these 100 controllers will need to be tuned simultaneously in the
Hmm.
first second.
Hmm. Hmm.
So maybe first 5 controllers will need tuning in the first hour, then in the next hours there will be problem in the next 5 controllers, and so on. So in one way, definitely it will not be like a heavily CPU intensive process, but it is good to have more powerful CPU or a processor which can definitely handle 100 controllers. SuperTune, mostly I would recommend for keeping monetary controllers stable and smooth, and to use SuperTune when you know that you will go through different operating ranges,
Hmm.
you have different grades, products, or capacities, what you need to handle through your operating time period, and when you are expecting to achieve or have nonlinear responses where one set of tuning parameters will not help you. And there are many processes like that. So I would put SuperTune on the top of the monetary controllers and on the top of the controllers which expect to have nonlinear response based on different regimes of operation of the process. For simple controllers which normally works well with only one set of tuning parameters, I wouldn't worry and I wouldn't waste time for SuperTune and this kind of the control.
Yeah, yeah, I hear what you're saying. So, like, if somebody who's listening or watching wants to learn more, where would they go? How do they get in touch with Pi Control Solutions and find out more? Maybe do I have a demo or get a quotation from you?
Oh yeah, definitely. We can do a demo. This is not a problem. We even have like a pre-recorded short sessions, like 5 to 10 minutes videos where they can see how the SuperTune and other our products are actually operating in the real life. And they can easily contact us on info@picontrolsolutions.com, or they can easily visit our webpage like www.picontrolsolutions.com, and under the contacts they will find all the necessary information to reach us and to get whatever they want to get from us.
Yeah, I want to encourage any viewers or listeners, if you have some loops that are giving you problems, take a look at this because I'll tell you what, this is the first time I'm seeing SuperTune, and I really just the whole concept behind it just seems like what you would want. It seems like this is the answer to a lot of our questions and our what we've been looking for years. So, and I'm sure there's other products too that can do something similar, but this is pretty interesting stuff. And Yvonne, I really appreciate you coming on the show and demoing this to our audience.
Oh no, it was a pleasure. Thanks you for inviting me again. And yeah, let's keep in touch.
Well, I hope you enjoyed that episode. I want to thank Even for taking time out of his busy day to come on the show and bring us up to speed on SuperTune. Now, if you did enjoy this episode, please consider giving us a like and a sub. And if you want to follow us or support us, you can do so over at automation.locals.com. You'll also find all of our training courses over at theautomationschool.com. With that said, I want to wish you all a very happy, safe, and healthy week. And until next time, my friends, peace.